Okay, so I did number 45. The Solar Maximum Mission satellite was placed in a circular orbit about 150 miles above Earth. Determine A, the orbital speed of the satellite, and B, the time required for one complete revolution. So what I did here is I drew out my diagram, and I have Earth and then the satellite above it. I define lowercase r as the distance from the center of the satellite to the center of Earth, and then I wrote out what we already know, which is the mass of the Earth and the radius of the Earth. So to make this easier, I converted the 150 miles into meters up here, and I got this number. And then I noticed that we're solving for the speed, so I'm using the distance equals rate times time formula, and the lowercase r is the radius of the Earth plus the 150 miles are the 241,463.4146 meters from the 150 miles. And then so this is now the lowercase r. And now I want to solve for t, because I'm going to plug it into this formula. So to solve for t, I'm using Kepler's third law. I plug in r, which is from here, and I plug in everything that we know. We know g, and we know the mass of the Earth. So then I'm now solving for t, and I get 5,359.20 seconds. I can then plug that into my distance equals rate times time formula and solve for v, which is 7,763.08 meters per second, or in scientific notation 7.76 times 10 to the third meters per second. And then the second part of the question is asking for the time required for one complete revolution, which is t. Since I already solved for that in this part, I can just then convert that into minutes, and I get 89.32 minutes.